welcome back to part 2 of confidence interval problems. Feel free to pause this video and try the problem on your own. In October 2015, the Gallup poll asked 1,015 randomly sampled adults the question, generally speaking, do you believe the death penalty is applied fairly or unfairly in this country today? Of these, 53% answered fairly, 41% said unfairly, and 6% said they didn't know. Find a 95% confidence interval for the proportion of all U.S. adults who believe the death penalty is applied fairly. Remember to verify the sample size assumption by checking the 3 conditions: randomization, 10%, and success failure. Okay, so let's check those before we do the confidence interval. So first of all, it says they asked 1,015 randomly sampled adults. So that takes care of randomization. We know that for 10%, our sample size can't be more than 10% of the population. So obviously, 1,015 randomly sampled adults is not greater than 10% of all adults. And then we have the success failure condition. And remember, success failure is when we do n times p and n times q, which has to be greater than or equal to 10. But if you recall, with confidence intervals, we don't have p, we have p hat. So we got to check n times p hat and n times q hat, which is just 1 minus p hat. Both have to be greater than or equal to 10. So n is my sample size. In this case, it's 1,015. And p hat here is the sample proportion of people that think the death penalty is applied fairly. So that would be 0.53. And then I need to do 1015 times 1 minus 0.53. And of course, if you multiply those out, this gives you 538, which is way more than 10. And then this is 477, which is greater than or equal to 10 also. So all of my conditions checked out. They're good. All right, now we'll do the confidence interval. So remember, my formula is the point estimate plus or minus my margin of error, which is made up of my z critical value times the standard error of p hat. Okay, so p hat here is 0.53. And since I'm doing a 95% confidence interval, remember the z critical value is 1.96. If you don't know that, you can refer back to this table. And another place you can look, if you go into the T table that's in your notes, and you go to, it's actually in the Canvas modules. If you go down to where the 95% is, all the way at the bottom, right here, there's your Z critical. It's 1.960. Okay, but we don't worry about the zero, so just 1.96 will suffice. So you've got 1.96. Remember, the Z critical value is just the number of standard deviations away from the mean. And then the standard error, remember, is the square root of p hat times 1 minus p hat over your sample size. And in this case, the sample size is 1,015. So when I do that, my margin of error ends up being 0.0308. And for my interval, I'm going to do 0.53 minus 0.0308, and I get 0.4992. And then 0.53 plus 0.0308, I get 0.5608. So to interpret that, what we're saying is, like, if we were to take samples of the same size, 1,015 people, over and over and over again, random samples, approximately 95% of them would contain the true percentage of all U.S. adults who think the death penalty is applied fairly, right? So here, you could just say, I'm 95% confident that the true proportion of all U.S. adults who think the death penalty is applied fairly is between 49.9% and 56.1%. So our sample told us it was 53%, but we're 95% confident it's the true proportion of adults who think the death penalty is applied fairly is somewhere between 49.9% and 56.1%. In this last problem, we're going to look at sample size. Like how large of a sample do we need to take to be a certain percent confident within a certain margin of error? So in March 2019 survey by Gallup of 1,019 US adults, 65% believe that global warming is due more to human activity than natural changes in the environment. The poll reports a margin of error of 4%. Suppose an environmental group planning a follow-up survey of voters' opinions on global warming wants to determine a 95% confidence interval with a margin of error of no more than plus or minus 2%. How large a sample does the group need? So if you'll remember, my formula for confidence intervals is p hat, so the point estimate, plus or minus the margin of error, which is the z critical value, z star, times the standard error of p hat. Okay, remember this part here is your margin of error. Okay, so we're only going to look at this piece right here because they give me the margin of error and I know that that's equal to this. So I can do some substitution here. I know I want my margin of error to be no more than 2%. Remember, 2% is 2 divided by 100 to turn it back to a decimal. So it's actually 0.02. So I'm going to substitute that in place of margin of error. I know I have a 95% confidence interval, so my z critical value is 1.96. And then the standard error is going to be the square root of p hat times 1 minus p hat over n. And p hat here is 65% or 0.65 because that was the survey that they did in 2019 that told them that 65% believe the global warming is due more to human activity than natural changes in the environment. So my p hat is 0.65. My q hat will be 1 minus 0.65, so 0.35. And then n is what I'm looking for because I'm trying to find out how large a sample does the group need. So when they're asking me for the sample, remember they're asking me for n. So you're going to need to do some algebra here to solve for n, okay? The first thing I'm going to do to get n by itself is to divide both sides by 1.96. So you'll get 0.02 divided by 1.96 equals this. So 0.65 times 0.35 divided by n. I'm just going to do 0.65 times 0.35, which equals 0.2275. Okay, now I need to get to that n. So to do that, I need to get rid of the square root. And in order to get rid of the square root, you're going to use the inverse and square both sides. So far that's what I have. And what I'm left with is this. The square root's gone. And you're left with that. Okay. Now, if I want to solve for n, I can multiply both sides by n. And you're left with this. And then to get n by itself, we're going to divide both sides by this. Okay, so now all I need to do is just type this mess into the calculator. And if you prefer, you can change that to a decimal, but don't chop off the too many decimals. I would round to at least like 4 places if you're going to. But I'm just going to type that whole thing in right there. One way to do that too, remember, is you can go to alpha y equals, and the fraction palette comes up. So you can just click on that, and then it's real easy. It's 0.2275. And then I'm going to divide that by, so I'm going to hit the down arrow, and then you need parentheses. It's 0.02 divided by 1.96. Close your parentheses. Okay, I made a little mistake there. Let me delete that. All right, close your parentheses, and then remember to square it. So you're going to hit the x squared button, and then hit enter. And this should be, sorry, not 1.92. It should actually be 1.96. So that's not right. It's 0.2275 divided by, and let me redo that. Okay, you're going to go to alpha y equals, and then hit the number 1, and it's 0.2275, and then hit the down arrow, and then parentheses, and it's going to be 0.02 divided by 1.96. Close your parentheses, and then remember to hit the squared button, which is the x squared button, and then enter, and you get 2184.91. You always round up 1, okay, to, kind of, I guess, make up for any rounding errors that could occur. So 2184.9 is going to round up to 2185. So always go up 1. So this gives us 2184.9, which you're always going to round up. So it'll be 2185. So in other words, their sample size, they need to have at least 2,185 people in their sample if they want to be 95% confident with a margin of error of no more than 2%. And that is it for confidence intervals. If you have any questions, please feel free to reach out.